Let's be real, when you picture a global oil and gas company, you're probably thinking about these huge offshore rigs, right? Massive refineries, all that heavy machinery. But what if I told you their most valuable asset wasn't actually the oil, but their data? We're going to break down how one energy giant took a total data mess and turned it into a billion-dollar strategic advantage. So here's our game plan. First, we'll dive into the massive problem they were up against. Then, we'll look at the universal standard they found that, honestly, changed everything for them. We'll walk through their simple but super powerful three-step plan, get into the nitty-gritty of building a digital twin, and finally, we'll reveal the huge payoff for getting all of this right. All right, so let's set the scene. Our story starts with Nexen, a huge global player in the oil and gas world. And right at the core of their entire operation was this giant tangled knot of a problem. Their data was a complete mess. I mean, information on equipment, maintenance, costs, it was scattered everywhere, it was inconsistent, and a lot of the time, it was just missing. And this wasn't just a little untidy, It was actively stopping them from running their business the way they needed to. This slide really gets to the heart of it. Imagine you're trying to ask a pretty basic question, like, hey, how often are these specific pumps failing across all of our sites? Simple, right? Wrong. For them, that question would kick off this massive manual data mining project. People would have to dig through dozens of different systems, spreadsheets. It was incredibly slow, super expensive, and honestly, you couldn't even trust the answers you got back.
And here's why it was such a big deal. We're talking about a company pulling in nearly $3 billion a year. When you're operating at that scale, tiny little inefficiencies caused by bad data, they don't just add up, they multiply. They explode into enormous cost, and even worse, major safety risks.
So Nexen knew this couldn't go on. They had to fix the very foundation of how they operated. So they started a search. But they weren't looking for a fancy new piece of software. Nope, they were looking for a blueprint, a kind of universal language they could use to describe all their equipment the same way everywhere in the world. And this is what they landed on, ISO 14224. Now, I know what you're thinking. An international standard sounds incredibly dry, right? But stick with me here. Think of this as the Rosetta Stone for industrial equipment. It's a proven, internationally agreed upon rulebook for how to classify, describe, and track every single nut and bolt they owned. This was the key to ending the chaos. So with that rulebook in hand, Nexen put together a really clear, actionable plan. This became their roadmap to totally transform their data. And their approach was, well, beautifully simple. It all came down to 3 steps. First, standardize how everything is structured in the system. No more weird one-off ways of doing things. Second, use a detailed taxonomy, which is just a fancy word for a classification system, to capture all the specific details of every single machine. And third, and this part is absolutely critical, they had to change their day-to-day work processes so that good, clean data was getting captured right from the very beginning. Okay, now we get to the really cool part, how they actually built this thing. We're going to deconstruct what's essentially a digital twin, a really precise digital mirror of all their physical stuff out in the real world. So the foundation for this whole digital twin idea is something called a functional location hierarchy. And the best way to think about this is, it's like the Dewey Decimal System at a library, right? It's not just a random list of books. It's a logical system that tells you exactly where every single thing belongs in the grand scheme of the entire facility. And this visual just lays it out perfectly. You start way up at the top with the whole power plant. Then you drill down into one system, like power generation. From there, you go deeper to one generator, then to its pump systems, all the way down to one specific pre-lube oil pump. Every single item has its own logical, traceable home. So what this means is that those crazy long, complex asset IDs are no longer just a random jumble of letters and numbers. They're actually a code. This table shows you how it works. YEM is the business unit, CPF is the facility, PMP tells you it's a pump, and so on. You can literally read the ID and instantly understand that object's entire story. But this brings up a really, really important question. The system can define the spot where a pump is supposed to go, but what about the actual physical pump with a serial number that you can go out and touch? Are those the same thing? The answer is no, they're not. And this distinction is key.
The system brilliantly separates the functional object, which is like the job description for pre-lube oil pump number 1, from the materialized object, which is the actual pump with serial number 1234 that's currently doing that job. It's just like a job title, right? The title exists whether someone is in the role or not.
So let's trace how this actually works. The hierarchy we talked about defines a functional location. That's the specific spot where something gets installed. And that spot has certain requirements. Then you have the actual physical pump, the materialized physical object, with its own specs. The system's job is to be the ultimate matchmaker, perfectly tracking when that specific pump is installed into that specific spot.
Okay, so we've been way down in the technical weeds, but why does all this meticulous organizing actually matter? Let's zoom back out and talk about the real-world value this whole thing unlocks. This quote right here from the source material, it just captures the payoff perfectly. Because the system knows the requirements of the job and the capabilities of the part, it can make sure you never ever install a pump that isn't up to the task. I mean, this is a massive leap forward for safety and for reliability. You always have the right part for the right job at the right time. So the big takeaway is that good data is like a superpower. Suddenly, you get global consistency. You can finally do real predictive maintenance because you're comparing apples to apples across thousands of pumps. You start making smarter, data-driven decisions about costs and safety. And this is a big one. You get rid of all that wasteful manual data mining. The power here is just immense. And that really brings us to our final thought here. Nexen did all of this for pumps and engines in the incredibly demanding world of oil and gas. So it kind of makes you wonder, if organizing data about physical machines can create this much value, how much untapped potential is just sitting there right now, disorganized and hiding, in your own data?